All right, in the next couple of examples, we're going to talk about a frequency distribution. Now, there's a saying that says a picture is worth 1,000 words. It helps a lot if you just give people a random set of numbers. It's hard for them to draw conclusions. It helps them a lot if you put it in some sort of chart or picture. So that's what we're going to be looking at, okay? If you think about it, if you ever took the ACT, the science part, it's mostly all charts and data. Most students just look at that and they don't read the actual stuff until they can't find their answer in those charts and that data. So it's just one way to make it easier for people to draw conclusions. Okay, so a piece of data is called a data item. We're going to collect it into a frequency distribution. Okay, so on this one, we're going to construct a frequency distribution for the data of the age of maximum yearly growth for 35 boys. So there are 35 pieces of data here. You cannot draw any conclusions just looking at that. So here's what you need to do. Put it in order from lowest to highest. They don't show this, but you really should put it in order, okay? Once you have all of those numbers in order, then you can make a chart like this, okay? 10 was the smallest age, 18 was the highest age. So we have 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now, if you go over here, how many 10s were there? Just one. How many 11s are in this group? Two. How many 12s are in this group? Five. How many 13s are here? Seven. Okay, so this column is called the frequency. Frequency means how many are there. Always add up your frequencies when you're done and make sure you get 35 because it's really easy to miss one and leave one out. So if this adds to 35 and you had 35 pieces of data, you know you left nothing out. Now we can use this to draw conclusions and they talk about that on the next page. What's a couple of things you can draw from this? Well, maximum growth for subjects occurred between the ages of 12 and 15. So if you look at this chart, see how between 12 and 15, most of the higher numbers are there. That's when maximum growth occurred. They also said the number of boys who attain their maximum yearly growth at a given age increases until 14, and then it decreases after that. See how it keeps going up until you get to 14 years of age, and then it starts decreasing. So you can learn a lot from a chart that you could not learn from just looking at the raw data. Let's look at another one. On this one, we're going to do what's called a grouped frequency distribution, okay? In other words, we're not going to list all of these numbers. We are going to group them from 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. That's how we're grouping it, okay? Now, there are actually 10 pieces of data in each group. If you count that out on your fingers, starting with 40 and go all the way to 49, it's 10. That's called your class width, and the width should always be the same, okay? When you get to statistics, that's one thing you'll learn. You need to keep it the same. So if we go back and see how many pieces of data were between 40 and 49, there's actually 3 between 40 and 49. If we go back and we look at 50 to 59 and we count all of those up, we find out there are 6. There are 6 between 60 and 69. There are 11 between 70 and 79. There are 9 between 80 and 89, and there are 5 between 90 and 99. Always add this up. It adds to 40. You had 40 pieces of data, so you know you didn't leave anything out. It's much easier to make conclusions once you have a chart and not just a bunch of random numbers.